We are back. No, not audible.
Yeah, audible.
So now we'll go to the second session, which is the concept of variable. So maybe this session, you might think that this is, you guys already know each and everything, but again, you can take it as a revision because we need to explain this also. So we'll start with this concept of variable. So in general, whenever we start any research, we go with the draft proposal and we have our research question. In research question, generally we have this format of pie chart where P stands for population, I stands for intervention, C stands for comparison if it is an intervention study, or exposure. If it is not an intervention, then it can be exposure. Then you measure the outcome. And then this outcome, again, it depends whether you have this time or not, whether T stands for time. But this research question or objective, whatever, whenever we frame, all these things have got something which we measure. So this measurement process is the crux of the research because we measure and then we analyze and then we hypothesize. So what do we measure? So we measure these variables. So these variables are the individual. So what are these variables? So variable is something which is varies. Varies means it varies from one person to the other person, and that is liable to change. That means it will not be same for two people. There will be variations. That's how, or that's why the name variable is. So it is a something which is liable to change, or it is liable of being varied or alterable. Like there are varying weathers, there are varying moods. All these are variables. So it is a characteristic. So variable is a characteristics. And then on the basis of that variable, which we discussed in the data entry, like one column is for the one variable. So it varies from one person to another person. And that's how those persons are in the rows. So those variables which we create, that is always in column. And the persons or the people whom we recruit as our study participants, they will be in the individual row. So like this person has uncountable number of variables, but what do we measure? So variables which are important for us. And how do we know that that is important for us? That means it is in line with our research question or with our objective or with our aim. And so it depends on our research, and we'll measure only those variables which are needed for us. So like in this case, you can see if it is like there's a whole, so I am planning to do something on the myocardial infarction. So let's say I want to see what is the blood pressure of myocardial infarction. People who are suffering from MI or who had a previous attack of MI, then this is my whole population of people of these MI cases. And then from those cases, if I take a sample. So generally what we do, this we discussed in the session of sample size also, that we cannot study each and everyone in the population because it's not possible for us. So then what do we do? Should we stop doing any research? So no, what do? We calculate something on a subsample of it or a sample of it. And that's how we calculate the sample size, that how much sample is needed to prove my hypothesis. So this sample calculation is based on certain parameters. And that's a separate playlist which is available. So those of you who want to go and see this, you can see that on the YouTube Merit India channel. So this MI, let's like on the basis of some size, I have calculated this sample of the MI from this universe. And then from that, I pick up one person. And this one person has got many variables. Let's say it has got age and the gender and probably a race, then any previous attack of cardiovascular disease or history of cardiovascular disease, or the serum cholesterol values. So this is known as the variable. And what is a datum? Datum is a singular of data. So a datum will be the individual value. So if I say that this person is of 45-year-old, male, white race, and the there is a history of cardiovascular disease, and the value of serum cholesterol is 230. So this will be your single data. And when you have many, so let's say if I have taken 10 data, then this whole bunch of 10 data is known as the data. So data is the plural, but we always use this data term. Why? Because generally we never have single individual where we perform a research. We have got a set of people. That's why we always use this term data, not data. So, and then we have got final these values. So let's say if these 10 people are there in my research sample, 10 people are there out of this total universe. And so whatever statistics I'll calculate, that is known as the sample statistics. So I'll have a sample statistics for this age. I'll have sample statistics for gender, for any history of cardiovascular disease, or for the serum cholesterol. And then if, like, for a hypothetical situation, if you measure everyone in the population, so then this, suppose it is the, let's say it is the 10,000. So this is again known as the data. But again, if you measure everyone in the population, then that particular is value, the statistics is known as the parameter. So remember P for P. So when you have the, no, measurement of the population, that is known as the parameters. And when you have got measurement of the sample, you call it as a statistics. So S is for S and P is for P. So for sample, we use the term statistics, and for population, we use the term parameters. So that's why if you measure the everyone in the population, you've got a population parameters for age, population parameters for race, for gender, for history of cardiovascular disease, and for serum cholesterol. So for any measured variable like age, gender, or MI, normally your sample statistics will never be equal to your population parameters. There will always be some discrepancy between these two values. And that discrepancy is known as the sampling error. Because you can never measure everyone, so there will be some amount of error. But the bigger the sample is, lower this discrepancy will. So that's why we say that we always emphasize on a large sample or on an adequate sample. I should not be using this term large, rather I should be using this term adequate sample. So again, let's see the various terms. So a variable is something which is liable to vary, which keeps altering from one person to another person. And in any data entry exercise or in any data entry sheet, whether it is Excel or JAMOVI or SPSS, we have one column for one variable. And then next is your data. So the set of data or the measurement or observation is known as the data. Data set is again collection of these measurement or observation. And what is a score? A singular value means the datum which we have discussed. So that is the value of those singular or a single observation is known as the score. Parameter is for the population, like we have studied. P is for P. So any numerical value that describes population is known as the parameter. And any numerical value which describes the sample, that is known as the statistics. So what is statistics basically? So it is a science basically in which you organize your data, you learn how to organize the data, and you try to infer. So basically, if somebody shows you a data set, you will not be able to infer anything. So rather than based on some subjective feeling, you try to make an inference on objective data set which you have collected. So how do we yield data? So we yield data by the observation. So in this example, you can see there are various pictures. Here the person is showing some some gesture. Here it is a like blood pressure. Here you can see there is a thyroid swelling. This is the newborn baby. And this is the abdominal circumference or the waist circumference. So these are just observation, and we measure these observation. And in research, we do the measurement. So like this is the color, you can see Here you can see this is the whether the baby has cried or not. Here you can see the baby weight. This is the temperature of the baby. And again, for the purpose of analysis, we assign a numbers to the various like object or events according to a rule. Like I think Dr. Lokesh or some person has asked, like whether we should be using always be giving, or is it mandatory that we should give numbers to all these variables? So generally we should give numbers to all these variables, because then it makes the analysis or the task of analysis easy. So, and this is like measurement. In the measurement also, what we do, we give a number to these variables or the measurement. And then how do we give these numbers? So now there are various scales of measurement. And this can be remembered with the term which is known as the NOIR, N-O-I-R. So where the N stands for nominal, O stands for ordinal, I stands for interval, and R stands for ratio. So I know maybe many of you know these concepts, but still just I want everyone to be on the same page. So that's why we are revising these concepts. So you may find this as a repetition, but bear with us till the time you find something which is new to you. So this nominal measurement, let's say, how do we define nominal? So nominal is we give number to some measurement. Let's say this categorical means there are some quality or traits. But if you reverse the number, the meaning does not change. That we mean by nominal. Means here you can see in this picture, we have given 1 to male. And I think in the exercise which we have given to you, where you have entered the data, there also you have given a number to it. Let's say 0. I think Dr. Suresh has given 0 to male and 1 to female, or any other number. So whatever number you give to male and female, if you change these numbers, the meaning does not change. That means if I give 2 to male and 1 to female, then also the meaning remains the same. So that's the example of nominal. So any traits, like let's say color of the eyes, or even if like one person was saying the blood group. So if you give like blood group 1, 2, 3, 4 coding, if you reverse these coding, then again the meaning does not change. That we mean by the nominal. Second comes your ordinal measure. So in ordinal, what do? We basically, if you see in ordinal, so in nominal, in ordinal, if you see, there is an order. So there is a mild, there is a moderate, and there is a severe. So if I say, if you take the example of pain, so pain has got 3 levels, and again pain perception is we call it as a little subjective. So one person is saying that I am having a mild pain. Some person might say I am having a moderate pain, and some person can say I am having a severe pain. So although here also I'll have to give a number to it. So I will say that I will give 1 to this mild, 2 to this moderate, because this is higher than mild. I know this is higher than mild. And 3 to severe, because it is higher than moderate and mild both. But again, here number, the 2 says that it is higher than 1, and 3 says that it is higher than 2 and 1. But if you see the difference, I cannot say that the difference between 1 and 2 will be same as 2 and 3. Why? Because it is not exactly measurable. Pain is something which is a quality, and it is a qualitative measurement. Although we have got different scales, and similar thing you will find with the Likert type of scale, all where you write like highly agree or highly disagree. There you cannot say like distance between these two. What is the distance? So that you can say that distance between highly agree and agree is same as the highly disagree and neutral. So that's why we say that these are the ordinal scale, where if you increase the numbers, definitely the measurement value in subjective term will be high. But exactly you cannot say like difference between mild and moderate is same as the moderate and severe. So this type of measurement is known as the ordinal measurement, or this measurement scale is known as the ordinal scale. So pain is one classical example. All those perception you measure in scale, like whether it is empathy, whether it is, you know, uh, depression in this PHQ-4 also, which we have given it to you, that is again a ordinal, because you were supposed to answer it in the 0, 1, 2 and 3. So that's a kind of ordinal. Again, in ordinal we say that if your level of measurement is 5 or more than 5, then it starts behaving as a continuous one. That means in that case you can treat those variables as a continuous or a scale variable. Third comes your interval measurement. So interval, the example of interval measurement is the time. So time is like, you say like it is 10 and 11, and then it is 8 p.m. and 9 p.m. So if you see the difference between 10 and 11 a.m. is 1 hour. And the difference between 8 and 9 p.m. is also 1 hour. So that's why we say that difference is same. That's why we call it as an interval measurement. That means the difference between these two is same, but it doesn't have an absolute zero. What do we mean by absolute zero? We'll see in the subsequent slide. Just hold for some time. And then comes the ratio measurement. So what is a ratio? In ratio, you have got an absolute zero. That means if my age is, let's say, if there is one girl whose age is 20, and then there is a one girl whose age is 21. So I can calculate a ratio between 21 and 20. I can also calculate a ratio between 22 and 20. For example, because it has got an absolute zero. So for example, now this is the example. So can you tell the difference or the distance between these two measurements? So like here I have given the example. One weighing scale, it is showing 10 kg. And so first focus on this. I think fan, can you switch on the fan? So these are two, you can see, this is showing 10 kg and this is showing 5 kg, right? So if I ask you the difference between these two, I can say, yes, the difference between these two is 5 kg. Again, if this clock is showing 10 a.m. and this clock is showing 5 a.m. So I can say like difference between these two time is 5 hours. Okay. Now coming to next. Can I say here that 10 kg is twice the 5 kg? Here, can I say this? That 10 kg is twice the 5 kg. Please answer yes or no. Yes? Can I say that? That 10 kg is 5 double of 5? Okay. But can I say that 10 a.m. is twice than 5 a.m.? Can I say this? Like
No,
10?
no,
No, we cannot
no.
say. Why not? Because there is no absolute zero. For convenience, we have said that, midnight 12 we take as zero, and then we calculate time based on that, like AM and PM is there. And that's why you will see many times, like it's not AM and PM, and these days it's like 10:22, like they follow this 24-hour, this thing. Like they start from zero and then comes to this 24. So
Ma'am, a small query. Is it necessary to have a zero? Example, we have 14 and 7. In that, there is no zero. I
where
mean,
14?
what do you exactly? Suppose you have got 14 kilograms and 7 kilograms. So
Okay.
we can say, so I mean, you have explained it by using zeros in both the examples, the previous one also, 20, 21, and this also. So can we say, for example, we have got 14 kilograms and 7 kilograms. Obviously, it is twice of that, but does not have a zero.
Yes, it has a zero means, I think you are not getting me right. Zero means absolute zero. That's why you can take out a ratio. Are you getting my point? This 7 you are telling in context of what? If you doesn't put anything on that weighing scale, what will it measure? Tell me that.
Okay, it will be 0.
It will be 0?
Yeah.
If the weighing scale is lying as such, and I have not stepped up on that, or you have not put anything on that, can you tell it will show 0 or it will not show anything? Maybe it will on or it will show 0. Okay. So it has got something as 0. It has got a value of 0. But in context of time, you cannot say. That's the meaning of 0 here. That it has got an absolute 0. That's why you can take out the ratio. Where if it doesn't have absolute 0, then you cannot take out a ratio. So all the variables which generally we measure, the biological parameters, like let's say any hemodynamic parameter, whether it is systolic blood pressure, weight, height, then let's say if you go by this hemoglobin, creatinine, any blood measurement or anything you measure on an individual, that is a type of ratio scale because it has got an absolute 0. Okay, like for reference, there is something known as 0 mile. I think in Patna also we have got, and in your area also, there is something known as 0 mile. Do you agree? And you measure the distance.
Yes. From every place has got a point from where you measure the distance, and you're right. You'll be having some place like in Pune, it is the post office which says 0.
Yeah. So that will be again all that distances that will be measured using that, because then you have got a reference point. So that's how we mean by 0. Means, all the distances which you measure, that will you take that. I mean, that you cannot say that it is 0, because if you take some other point as a 0, then it has definitely got a distance. Are you getting me?
So the idea here is that, ma'am, 0 is taken as a reference point rather than a numerical value.
Yes.
Okay.
It has got a reference point, and then that's how you can take the ratio of it. Whereas in case of time, and I think time is the time, and there's a temperature also. These are two variables generally which is there as an interval. Otherwise, generally, that's why you see that in SPSS or in JAMOVI or in any software, together these interval and ratio, together we call it as a scale variable. We don't differentiate between these two. But just for academic purpose, I have explained it. Otherwise, for all practical purpose, we'll consider this interval and ratio together as scale variable. Okay, am I making sense to all of you?
Yes, ma'am.
Okay, thank you. So now coming to, so in case of the, again talking to the same which Dr. Ravi was saying, so the difference, the reference point is actual in the first case, whereas it is arbitrary in the second case. So this was if you see the levels of measurement and hierarchy of these measurements, then nominal has got the weakest, and then ratios the highest one. Means highest means in the hierarchy. Like we say now, in case of research, that cross-sectional is at the bottom, and then RCT and the again that is at the highest hierarchical level. So similarly, if you go by the levels of measurement and the hierarchy, the nominal is the weaker and the ratio is the stronger one. So that's why we say that you should always collect the data according to the inherent nature of the variable. Many times you will see, we have often faced this, especially in the clinical setup. Whenever they collect the data, since beginning they start categorizing it. Like we have received several data set where that they collect the data in age as a categorical variable. So they write like age between 20 to 22, 23 to 24, or maybe at the 5 year. They don't write the the real or the absolute age. So we always encourage that, since the ratio is the strongest in the hierarchy, so if any variable, the inherent nature of the variable is of that of a scale variable, then you should not collect it as a categorical variable. Together, these nominal and ordinal, we call it as a categorical, and interval and ratio, we call it as a scale variable. Again, ordinal, I have told you, if the ordinal has got 5 or more levels, then we call it as a scale variable also. And in all, that's why in all that scale development and all scale validation and that tool, you will see that all these Likert scale, generally we encourage the participants to collect the data of any perception or any tool at least in 5-point scale, because then you can perform all those statistical analysis which is meant to be performed on a scale variable. Because why your these understanding is needed, because then you will be able to perform all those analytical steps which you will see in the higher analysis, because there again these basic rule comes: what is a nominal, what is ordinal, and whether you can interchange these variables or not. Now there is something known as the dependent and independent variable. This also I know that most of you know, but just to revise once again. So in this picture, what can you see in this picture? So here you can see there are 3 water drops. This is of a smaller size and this is of a bigger size. And then these are the 3 pots with a single leaf plant. So in this case, here you can see like there are different amount of water and this is your plant. So if I ask you which is the dependent variable and which is the independent variable, can you say whether water is independent or dependent, or flower like these flowering plants are independent or dependent? Which one is the dependent and which is the independent? In this case, like let's see. So plant is dependent, right? And the amount of water is the independent variable. So here the size of the plant is different. The number of leaves are different. Yes. And the plant status is also different. So here the amount of water and effect of plant on plant. So in this variable, which one we can change? So generally we can change the amount of water. So whatever we can change, that is known as the independent variable. And whatever we cannot change, which the change we want to see it on another variable, that is known as the dependent variable. So independent variable in this case is the amount of water, and dependent variable is in this case the number of leaves or the the plant, the size of the plant. Again, it is not the inherent nature of the variable. Any variable can be dependent or independent depending on your requirement. So now there is something known as the quantitative data. So whatever data you measure on a numerical scale, which you measure in the numbers, it is known as the quantitative data, which we also call it as a scale variable, like age, height, weight, triglyceride, number of people, cholesterol. All these are the quantitative or the numerical data. Again, it is of 2 types. There is something known as the discrete variable and there is something known as the continuous variable. So what is the difference between these two? Discrete there is a gap between the values. That means if I say total number of total number of children in a family, then you cannot say it is like 3.2. Why? Because it will be in a whole number. The number of people admitted in a ward, it cannot be 4 like 10.2. It should have a discrete number. So that's even the quantitative data. There are many values which cannot be a fractional value, that is known as the discrete value. And then there is something is the continuous data. That means gaps, there is no gap in between the possible value. Like all other variables, like whether it is creatinine or hemoglobin or urea nitrogen, even blood pressure or the weight. So all these are the continuous because the fractional values are possible in such case. Next one, your categorical data. So we will often use this scale variable and categorical variable in all the type of analysis. And if you see, I'll show you the interface of JAMOVI. There also you can see that these types of variables you have to enter when you start your data analysis and you start your process of analyzing the data. So this categorical data means you are giving a number to particular data, but it is a characteristics. That number does not represent the quality. So basically it is a characteristics or trait, and number are only there for labeling purpose. And the number, like in this categorical, both the nominal and ordinal, that comes as a categorical. Ordinal having less than 5 levels are again known as categorical. Ordinal, if they have got 5 or more than 5, you may treat them as a scale variable. And again, nominal, they are again like gender of a person, the socioeconomic status. Socioeconomic status, if it is having a three values like low, medium, and high, again it is ordinal in nature. It is, you cannot treat it as a continuous. Or skin color, fair, wheatish, or dark, or pain, mild, moderate, severe. Or religion, Hindu, Christian, Muslim. Or improvement, mild, moderate. So both in this case, you can see it is both the example of a nominal. If you see male and female, it is nominal. If you see socioeconomic status, it is ordinal. If you see skin color, it is nominal. If you see pain, it is ordinal. Religion, what is religion? Ordinal or nominal? Now you type in the chat box.
Nominal.
Yes, very right. And what is improvement?
Categoric. Sorry. Ordinal.
Very right. So now you know that categorical can be nominal and ordinal. Ordinal, when there is a definite order, you cannot change the order. In nominal, if you change the number also, the meaning does not change. So in measurement scale, we have got categorical variable. Both nominal and ordinal comes as a categorical. And interval and ratio together, we take it as a scale variable. Ordinal, having 5 or more than that level, also comes here as a scale variable. Then you treat them as a scale variable. So why there is so much of importance? Why I have spent so much time in explaining to you? We could have straight away go to JAMOVI and start analyzing. Because the data, the inherent nature of the measurement purpose or the inherent nature of the variable tells you how to analyze the data. So that's why categorical data, they behave differently, therefore they are studied differently. And in case of, you will see assumptions also. In all these analysis, we'll study the assumptions. So the nature of the data, it tells you what type of analysis needs to be performed. So that's why it is important to know the inherent nature of variable, the type of measurement of scale. This is again one example on studying on coping and perceived stress among adolescents. So this is how I was telling you here. Since beginning, the person has categorized the data like age 14 to 16. Otherwise, here it should be in the continuous. Again, you can see gender. It is a categorical religion. So I think you know all this. So I'm just skipping this. So now, few more activity for you people. Identify the number of variables in this temperature. If temperature is the variable, how many variables are here? Like if you have to enter temperature and I'm taking temperature twice, morning and evening, how many variables I should have? Means how many, do I need one row, one column, or do I need two column? So Farzana is, and everyone is asking, yes, two. Because I'll have temperature 1 in the morning. And temperature is a what type? First you write temperature is a which type of, it is a, now we'll only talk in the categorical and scale. So which type of measure, whether it is a scale variable or is it a categorical variable? Yes, so scale or a continuous, right? And then 2. Next one, symptoms. What is this? What is a symptom? Symptom is a scale variable or a categorical variable. First tell me that. Yes. So Dr. Keith,
Categorical.
right? Categorical, very true. And then how many columns? If you have taken
4.
yes, 4, fever, cough, body, yes, very right. Comorbidities, type of variable, categorical,
Categ-
continuous.
Categorical 3.
Yes, categorical 3. Yes, Dr. Lokesh, Radha, Kirti, Pradeep, everyone written correctly. Now tell me this. Gravida 5, para 4, 3 live issues, 1 abortion. Tell me first tell me which type of variable it is. Continuous or scale? Scale.
Scale.
Again, in scale also I tell there were 2 types of variable, discrete or continuous.
Discrete.
Yes, discrete, because it cannot be like 5.5 or 4.2. Yes, and then how many columns do I need to have if I have this variable when I am planning for data entry?
4.
Yes. 4. Yeah. So now you got it correctly. Gender. Gender is a which type of variable?
Nominal.
Yes, nominal. But here I will not have two. Why? Because a person cannot be both. Either he will be male or he will be a female. So many times what participants do, like since beginning, they are in a habit of writing those many columns. So for gender, I will not have two column because one person can never be both. So I'll have only one column. Like one, either I can be a male or I can be a female. Okay. So this was regarding the basic concepts of variable. Now I'll start with the descriptive statistics and then we'll have breakout room. Means not before lunch. So till now, JAMOVI should I say first?
Transformation.
Oh, that's what. For that, though, I need to tell them the interface of JAMOVI. Okay. Then first, let's understand the. Okay. So I'll stop. I think not descriptive now. Probably first, let's understand this JAMOVI. So
Then complete transform. Complete.
So now coming to the JAMOVI. So yes, why then this question comes like many people they always ask like why to use JAMOVI and is it something this is a very frequently asked question like should we cite this and if I am performing analysis on JAMOVI will it be acceptable by the scientific community or by the publishing house? So yes, the answer is yes. Definitely all whether it is published, whether it is a BMJ group or it is Nature, whatever you see, there's a lot of references in the web and you can use the JAMOVI. So it was released in August 2018 and it got updated in 2019. And this JAMOVI, what you can do, like you can perform a basic statistics and this basic data analysis, when you install the JAMOVI, it comes with that package, this basic analytical package. But if you want to perform some advanced analysis, then you need to install the module, which we'll see how to do the module installation. But for basic, you don't need to install any module. But of course, those of you who are already doing analysis and who want to do again on JAMOVI, you need to install that additional one. Again, for meta-analysis also, like those of you who have attended the meta-analysis workshop or maybe the scale development workshop also, you know that you need a module installation in the JAMOVI. So for whom JAMOVI is recommended? So again, one very blanket sentence for this, that for all the researcher who want to do this, wants to do the analysis in the data set, you can do this analysis on the JAMOVI. And again, I will show you, there are two types of JAMOVI. If you just open the JAMOVI on Google, you will see that there are two types of interface or the download option is there for you. One is for the solid. Here, I think we have written 2.8, but now the version has changed. So you have to, please download this solid version. Don't download this current version because there are many modules which are not yet finalized in the current. So you might face some issues in the current module if you have downloaded that.